Hello everyone. My name is Dory Dane, and my today I'm going to present my paper about AIDanceFriend, a mobile application. In my today's presentation, I'm going to cover 5 points, including introduction, a demo video, some challenges and solutions I've faced when I developed the application, and some experiments I've used, and some feature developments and conclusions. So first is introduction. First, here's my self-introduction. My name is Yuanyuan and I go by Dory. I'm currently a high school sophomore. I am from Hill School located in Southern California. My hobbies include dance, tennis, Chinese musical instrument, and I have coded for about 1 to 2 years already. Yeah, and here are some inspirations of the AIDanceFriend. So as a K-pop dancer, I do dance coverings very often. However, there were always like a problem that I cannot grade my covers based on the similarity because comparing two dance videos and judge how similar they are is very difficult for me. And therefore, I got an idea that I could create a system that solve this problem. Ideally, the system allows me to upload my covering videos and the original choreography videos. Then it will use an algorithm to grade my cover based on its similarity with the original choreography. And most of the time, higher similarity means better. So the system will give me a letter grade back to judge my covers. And here's a flowchart showing how the application works. So from my inspiration part, which is last slide, I showed what's the basic principles of the application. But here's some details I would like to provide to you. So the application is a mobile application which allow users who like covering other choreography to compare the similarity between their covering videos and a choreography's dance video. So opening the application, the user is able to upload two videos from their devices. Then the user only needs to click the Analyze Video button to run the program. The program will process two videos sequentially, and we will use MediaPipe to gather outlines of the dancer's movements while iterating the frames in the video. Using MediaPipe to gather outlines of the movements, we were able to calculate the degrees of angles at the dancer's joints of every frame. There are 8 angles data each frame, and 8 angles of the frame will be stored in a list, and there's a list of lists which will store angles information frame by frame. After collecting data into 2 lists, we will cluster lists into 2 big lists in order to line up corresponding frames of videos. Lining up the frames, we are able to calculate the numerical difference of the angle from the 2 videos. Then we will utilize Flask to store 2 videos in Google Firebase, which allows us to show users their videos uploading history. In the end, there will be a letter grade shown to the user, which indicates how close their dance is compared with the choreographers. It indicates very slow, and D indicates merely close. So first, we use Flutter to create and upload a video page, which enables the users to click on the upload button and choose the videos from their own libraries, Google Drives, Google Photos, and etc. Then the library will input 2 videos to Python code that we wrote for analyzing videos. In the process of analyzing videos, we use MediaPipe to collect body's angle information. To calculate the angles information, we need to gather the positions, and which indicates by the X and Y coordinate, and which includes left shoulder, left elbows, and left wrist, right shoulder, right elbow, and right wrist, left hip, left knee, and left ankle, right hip, right knee, and right ankle, left shoulder, left hip, and left knee, right shoulder, right hip, and right knee, and something like that. Information of 3 points, endpoints of an angle, are the inputs of the function calculating the angle. The calculated angle function will perform the calculation of angle degrees by using the X and Y coordinates of every point. Then the function will return the rounded degree of the angle to the function that collects angle data. Taking the angle information from the calculated angle, the function will store all the degrees of the angles that are described in the previous sentence in the list. Now the iteration of the first video is over. After the iterating the first video, our application is going to repeat the steps of collecting data to iterate the second video. And then it will calculate the angle degrees, and we will perform a certain angle calculation. So after the data collecting we need from the two videos, we start to cluster the data that we collected. We cluster data by comparing all the angle information in a single frame based on the similarities of those angle information and the nature of clustering. We could line up frames appropriately. Then we use the algorithm below to calculate the difference between angles and generate the number grade of the uploaded videos, which is called average error in the algorithm. And after calculating the average error, we then translate the number grade to a letter grade. And I'm going to show you a demo video. So this video just shows how the application AIDanceFriend works. So basically you can click the upload videos to upload two videos from your own Google Drive on the phone. And then you just click the analyze video part. And then you can just like wait for a few seconds and after you wait, you're going to get like two videos. Like you can your videos that you uploaded is going to be shown on the page. And then when you scroll down to the bottom, you will just see a letter grade. So this letter grade A means like the two videos are similar, which indicates that your cover is kind of successful. So, and then here are some challenges and solutions during my development of this application. So first, oops. So first challenge that we have faced is comparison of the data. And this slide basically is like how can we compare the data of correct frames from the two videos. And so then since we use the method of processing two videos and collecting data sequentially, and the number of frames of videos may not be exactly the same, so it is hard for us to compare and analyze data by lining up frames of two videos. The second method we come up with is extracting the background music of the two videos and line up the music in order to line up the videos. However, it is also hard because many times the background music contains some useless like noises. So if you want to eliminate these background noises, there is a probability that some parts of the actual music will be eliminated unintentionally. So at the same time, although we could solve the useless noises problem, lining up through the video through music also contains a problem that after extracting and processing unrelated noises, it is hard to align the background music to the MP4 videos. Therefore, these traditional methods we thought are not really implementable. So later on, our solution for this challenge is to use clustering, which I just mentioned in the previous slide, is we wanted to use clustering to like line up the data information of the two different kind of the videos. So that's how we solve this problem. And the second challenge we have faced is storage. So testing many videos of the dance, we have observed that many videos have more than 1,000 frames. And if we want to store all the frames into our backend storage or the phone or computer, it will be a lot of work. So if we decide to store unnecessary information in the frames, challenge one will come again because storing information in frames will also face the problem of formatting and aligning on this information, which makes the challenge one more significant and like harder. So if we cannot solve the problem of lining up data by comparing the frames, it is hard for us to line up the data only with the numerical information such as angles. But however, clustering can also solve the solve this challenge, and which I mentioned in the previous video. And then is the scoring system. So for now, at this point, when we first created our scoring system, we were trying to average the angle difference of each frame and compare all the averages from all the frames. However, after we test some obvious test cases, 2 different dances videos with the same length and 2 videos that are exactly the same, we found that the result do not make sense. Therefore, we decided to create a new scoring system. So our updated scoring system is to calculate the difference between angle degrees of the 2 according frames from 2 videos, and we will add up all the differences from all the frames. Instead of taking the average of difference separately from each frame, we now take average of difference from the sum to different from other frames. Then based on the average error in percentage, we will give our users a letter grade. So if the average is like over 110, it is considered an F, and average errors that are between 90 and 110 are D, between 60 to 90 is B, and less than 60 is considered as an A. We don't give a letter grade C because after testing many cases, test cases show that B and C are actually happening too. There's like no big difference. So we decided to delete a letter grade C and remain A, B, D, F. The difference between those 4 letter grades are like more logical. And next, my experiments part. So first experience I have made is to a comparison between the YOLO V7 and the MediaPipe, 2 different kinds of the pose model. And as you can see from the diagram right here, the result the MediaPipe got is like so much better than the YOLO V7. So the YOLO V7 poster is single stage multi-person key point detector developed by PyTorch, is trained using the COCO dataset, which includes 17 landmark topologies. Segmentation supports both CPU and GPU, therefore it is not directly related to posture. In contrast to MediaPipe, a framework that can only detect one person, it can detect several people. MediaPipe only supports CPUs and the segmentation is built in. In this experiment, employing both poster models in CPU environment, we compare the performance of FPS on the fixed model input insights for record inference, where when we just like one person is represented on it. First, because 960 times 960 is a standard picture size, we ordered a YOLO V7 algorithm to forward past the images that have been scaled to that size. The person's posture was then collected for each frame of the recorded video. The results that the MediaPipe performance is much better than YOLO P7 in the CPU inference. When pre and post processing are not taken into an account, the MediaPipe may process the forward pass at a speed of 29.2 FPS compared to YOLO V7's average processing speed of 8.1 FPS. There is some effectiveness of several supervised learning techniques, which is basically AI models. So the goal of this experiment is to compare the effectiveness of several supervised learning techniques to the K-means clustering method. Several algorithms and several supervised learning models were employed in this experiment. We employ support vector machine, nearest neighbor, nearest centroid, and nearest component in this experiment. Initially, we created an algorithm that enables user to manually categorize pictures, frames from dance videos. Then we manually labeled a series of movies that lasted for around 5 seconds to 1 to n. With each number denoting a certain percentage of the dancers, about 400 photos were gathered from each label. However, a lot of pictures are share a striking visual similarity. We have over 100 photos after removing similar ones. We believe that this amount would be sufficient because there were few ways to get additional photographs of the people dancing, but we can also utilize data augmentations to mimic various camera angles and make the algorithm more accurate with changes in video viewpoint. The outcome demonstrates that with the data augmentation has a greater accuracy than without the data augmentation. So according to the study, the accuracy of the nearest neighbor, nearest central, nearest component, and support vector machine for the model with the data augmentation was 84.8%, 65.1%, 94.8%, and 79.8% respectively. Finally, the result revealed that the accuracy of the model without the documentation is 73.9%, 69.6%, 60.9%, and 76.8% of nearest neighbor, nearest central, nearest component, and support vector machine, respectively. We can see that all the outcome of the 4 supervised learning algorithm accuracy increase with the inclusion of the documentation. And then it's for some future development and also some conclusions of my research. So currently, some limitations of our work include the lack of complexity of the algorithm, and our current algorithm that do not seem to so accurate because it cannot return a user understandable number grade, such as 110%. Therefore, we may need to improve our algorithm with a more complex method in order to let it return a more accurate number grade, so we can return a number grade directly to the user in order to allow users to understand and compare their grades more specifically. And in the future, we'll need to try some more types of algorithm in order to solve the accuracy problem. And this algorithm should not only include numerical calculation based on angle differences, but more advanced math analysis elements. And that's all for my presentations. And thank you for listening.